Yo, 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 it's your boy Mr. B bringing you some maths, and today we're gonna do 3D trigonometry. Alright, check this out. ABCD is a cube. Find the value of BH. Alright, so here's the question. How do you do trig on 3D shapes? The answer is you don't. You just don't. It's not a thing. The whole thing about 3D shapes is you're going to slice triangles out of 3D shapes and work with that. That is the only new skill that you're learning today. Everything else you've done already. So let's take a look. We're finding the value of BH. So first of all, let me show you where BH is in the diagram. It's that guy over there. So what I'm going to do is I'm going to find a triangle that contains BH and I'm going to remove it from the 3D shape. Yeah, I'll show you how it looks like. So I'm going to find that triangle over there and I'm going to remove it from the 3D shape. How sick was that? That was pretty sick. So let's go. So I have now triangle BFH, and what do I know about this triangle? Well, I know what BF is because it's a cube, so BF is 7 centimeters. Also, I know that angle BFH is 90 degrees. How do I know that? Well, it's a cube and I took the triangle from BFH, so it has to be 90 degrees. Do I have enough information to find BH? Nope, I don't. I am missing either side of an angle, so what can I do here? What I can do is I can find the value of FH. And in order to do that, I'm going to do the exact same working out. I'm going to take a triangle that contains FH out of the 3D shape. So I'm going to take that triangle over there, triangle FHE, remove it from the 3D shape, and let's put the pieces of information that I know. I know that EH is 7. I know that FE is 7. How do I know that? Well, it's a cube, so all the vertices are going to be all the sides are going to be the same. And I know that it's a 90-degree angle, FEH. Cool, from there, everything falls into place, like dominoes. Look, I can use Pythagoras to find FH. So that will give me that FH is equal to square root of 7 squared plus 7 squared. If you're not sure how to do trig, go to my previous videos. You're going to see that in this video I'm going to skip a bunch of stuff. Which gives me that FH is 7 root 2. Now, why am I using 7 root 2? By the way, you just put on your calculator and it gives you 7 root 2. Why am I using 7 root 2? Why am I using third form instead of using a decimal? Because you really just want to round at the very last stage of your working out. If possible, you shouldn't round on the middle steps. Cool? So let's go. Let's take the 7 root 2 and put it into FH. Now I have enough information to find BH because I can use Pythagoras again. BH is going to be square root of 7 squared plus bracket, very important, 7 root 2 squared. Put that exactly as is on your calculator and you're going to get that BH is 12.12. Cool? I'm going to give you some questions to do now. It might be worth for you to write down the question in your book, then come back to the video at this point and do the working out the same as me, because the working out doesn't really change. It's always the same. Alright? Pause here, come back when you got an answer. You should get 8.66. New one. Pause here, come back when you got an answer. You should get 12.33. And another one. Pause here, come back when you got an answer. You should get 8.37. Cool? Let's take a look at a new question. Find the value of angle BHF. The working out doesn't change. You're always going to get a triangle out. That triangle is going to be missing a couple of pieces of information. You're going to take another triangle out to find those pieces of information. It's always the same. It's pretty simple. Now, angle BHF. Now, the cool thing about angles in 3-letter notation is you kind of know which triangle you're going to use because you're going to use triangle BHF. Cool? So I'm going to remove that triangle from my shape. Now, what do I know about this triangle? I know that BHF is what I'm trying to find, so I'm going to mark that in the diagram. I know that it's a 90-degree angle BFH. and I know that BF is 5 centimeters. I know that from the diagram. But sorry, it doesn't say BF is, listen, it's a cuboid. If CG is 5, BF is 5. Again, I don't have enough information here. That's almost always going to be the case with 3D shapes. So I need to find another side. So I'm going to find, you can either find BH or you can find, you can't find BH, I forget what I'm saying. We're going to find FH here. So we're going to take this triangle out. Does it have to be that triangle? Technically, you could use FGH, that's fine as well. I'm going to remove that triangle from my 3D shape. What do I know about this triangle? I know that FE is 4 centimeters. I know that FEH is 90 degrees. And I know that EH is 8 centimeters. From here I can find FH using Pythagoras. FH is going to be 4 squared plus 8 squared, which you put in your calculator and it gives you 4 root 5. I'm going to take 4 root 5 and put it back on my original triangle. And now I have enough information to find my angle. I'm going to skip some steps here, but which one to use, SOHCAHTOA or TOA to find the angle? Well, I have opposite and I have adjacent. I'm going to use TOA. So the angle H, BHF, is going to be the inverse tan of opposite over adjacent, so 5 over 4 root 5. Put that in your calculator as is, and you get that BHF is 29.21. Easy peasy. All right, let's try a couple of questions. Same thing, if you want to follow with here, that's fine. But it's always going to be, get your triangle that contains the whatever the question is asking you. That triangle is going to be missing a piece of information. You're going to use another triangle to find whatever information you need for your first one, and then finish the question. Cool? All right, pause here, come back when you got an answer. It should be 54.74. One more, pause here, come back when you got an answer. It should be 25.24. Pause here, come back when you got an answer. You should get 16.04. Alright, that's pretty much it. Let's do a recap. So recap, 3D trig is all about cutting 2D triangles out of the 3D shape. That is literally the only new skill necessary on 3D shapes. Everything else comes from SOHCAHTOA. Always start by drawing the triangle that contains the side angle you need to find. That triangle will be missing 1 or 2 pieces of information. You need to find other triangles in your shape that will help you find those values. And if you're not sure, find whatever you can. That's always going to be the case with angles and trig. When in doubt, find everything. Cool? And we could be done, but I wasn't sure if I was going to show you this because I don't like showing it for the first time. But this video has a little extra. Alright. There's a special case here. And the reason I don't start with the special case is I like you to be good at cutting triangles out of the shapes before you use it. But when you're trying to find a diagonal and your shape is a cuboid, so those two requisites need to be met. You're finding a diagonal and your shape is a cuboid. You can actually cut a few corners because the diagonal of a cuboid is the square root of the length square plus the width square plus the height square. Sir, that really looks like Pythagoras. Yeah, I know, it does. And it's pretty much the same idea, just for 3D. Now let's see. The only way that you can use this is if you're trying to find the diagonal. So either you're trying to find BH in this case, or you're trying to find CE, or you're trying to find DF, or you're trying to find AG. Do not, under any circumstance, use this formula to find any other sides. It has to be a diagonal. But if it is a diagonal, you're going to get that AG, in this case, is equal to 8 squared plus 4 squared plus 5 squared. Put that in your calculator as is, and you're going to get the AG is 10.25. Alright, that's it for me. Again, people get really scared of 3D trig. If you look at GCSEs, the amount of people that don't even attempt 3D questions is huge, but it's no big deal. You're slicing triangles out of your 3D shape and working with those. That's it from me. Hope this was useful. Borges out.